Now we are going to discuss the failure of wave theory of light or radiations to explain observations of photoelectric effect. We know that in the observations of photoelectric effect, that means the emission will be start at a particular frequency called as a threshold frequency. Also, there is no time lag between the emission of electrons and radiations incident on metal plate. But according to wave theory of light, we know that these radiations they are incident on a metal plate. This energy, if the intensity is large, then energy is large. It is the energy of radiation. It is independent of frequency. That means if the intensity is large, then energy it should be large, incident on a metal plate. But when this energy which is incident on a metal plate, then electrons which is present in the metal, they will absorb energy or accumulate energy, and when the energy of these electrons it is greater than the potential barrier of this metal and they can escape from the metal surface, and time required to accumulate energy it is few minutes to few hours it will be required there, and it is contradiction with the observations of photoelectric effect. That means it is an instantaneous process according to Einstein's theory, or we can say that according to quantum theory. But according to wave theory of light, the time required for the emission of electron it is few minutes to few hours. That means it is totally contradiction with the observations of photoelectric effect. So by using this wave theory of light, we cannot able to explain the photoelectric effect. Secondly, the emitted electrons they have kinetic energy. By using, we can say that the accelerating potential. That means potential applied to collector. But according to wave theory of light, the maximum kinetic energy is depends on the intensity of incident radiation. It is independent of frequency. So the maximum kinetic energy of electron it should be according to photoelectric effect it will depends upon velocity of electron. That means it will depends upon the frequency of incident radiation and independent of intensity of radiation. But according to wave theory of light, it will depends upon intensity but not depends upon frequency. This is also a contradiction with the observations which are made here. So the wave theory cannot able to explain the observations of photoelectric effect properly. To find out the time lag or accumulation of energy by the electrons to eject from the metal surface, we have to consider that work function, and this work function is nothing but phi 0. If phi 0 be the work function, then we can define this is nothing but the minimum amount of energy which is required or accumulate by the electron to eject from the metal surface. This much amount of energy is known as a work function, and it is always denoted by phi 0. By using this term or work function, we can able to find out or we can able to estimate the time required to accumulate energy by the electrons to eject from the metal surface. Work function can be measured in electron volt, and for different materials, that means metals, this work function can be different, and it is such that potassium 2.3 electron volt, sodium 2.4 electron volt, calcium 2.9 electron volt, zinc 3.6 electron volt, silver 4.3 electron volt, aluminum 4.3 electron volt, tungsten 4.5 electron volt, copper 4.7 electron volt, nickel 5.0 electron volt, and gold 5.1 electron volt.
According to wave theory of light, when radiation falls on a emitter plate, the electrons present on surface, they will accumulate energy and eject from the metal surface. The time required for the ejection, it will depends upon the intensity. We can estimate this time by using a suitable example. Radiation of intensity 0.5 into 10 to the power minus 4 watt per meter square falls on the emitter in a photoelectric setup. The emitter is made up of potassium and has an area of 5 cm square. Let us assume that the electrons from only the surface are knocked off by the radiation. According to the wave theory, what will be the time required to notice some deflection in microammeter, which is connected in the circuit, and the radius of potassium atom is 230 picometer and work function of potassium is 2.3 electron volt. We have given that the intensity of radiation 0.5 into 10 to the power minus 4 watt per meter square, area of cathode which is equal to 5 centimeter square, or which is equal to 5 into 10 to the power minus 4 meter square. The radius of potassium atom 230 picometer, which is equal to 230 into 10 to the power minus 12 meter. Work function of potassium, which is 2.3 electron volt, or we can say that 2.3 into 1.6 into 10 to the power minus 19 joule. We can find out number of electrons present on the surface of emitter or cathode can be approximately calculated assuming that each potassium atom contributes 1 electron and the radius of potassium atom is 230 into 10 to the power minus 12 meter. The number of electrons which can be determined by using a formula, the area of cathode or emitter divided by area covered by one atom, which is equal to 5 into 10 to the power minus 4 divided by pi r square, where this 3.1415 multiplied by 230 into 10 to the power minus 12 multiplied by 230 into 10 to the power minus 12. After calculation, we get the value 3009 into 10 to the power 12 electrons. Incident power on cathode is 0.5 into 10 to the power minus 4 watt per meter square multiplied by 5 into 10 to the power minus 4 meter square. This is equal to 2.5 into 10 to the power minus 8 watt. Wave theory assumes that this power distributed over the whole area of the cathode is uniformly absorbed by all the electrons. Therefore, the energy absorbed by each electron in 1 second is 2.5 into 10 to the power minus 8 watt divided by 3009 multiplied by 10 to the power 12. After calculation, we get 8.31 into 10 to the power minus 24 watt. The work function of potassium is, which is equal to 3.68 into 10 to the power minus 19 joule. Hence, each electron will require minimum 3.68 into 10 to the power minus 19 joule of energy to be knocked from the surface of cathode. The time required to accumulate this energy will be 3.68 into 10 to the power minus 19 joule divided by 8.31 into 10 to the power minus 24 watt. So we get 0.443 into 10 to the power 5 second, which is about half a day, and this much time which is required to electron eject from the metal surface.